So for this video, I'm calling this the intro to chapter 4, if you will. It's technically 4.1 and 4.2 in your book, if you have a book. I'm basically going to split this video into two parts. So this would be part 1. Chapter 4, we're dealing with triangles, and we're mainly going to get into proving triangles as a whole are congruent. But for the first part of this intro to chapter 4, we're just going to kind of just do a little quick intro/review of what you know already about triangles. So the first thing about triangles is their interior angle sum is always equal to 180 degrees. This is something you probably know from a previous class. So if you ever asked to give the value of x in a situation like this, you could do something like 35 plus 110 plus x is 180. Combining like terms, you get 145 plus x is 180, and then just subtracting 145, x is equal to 35. So this angle is 35 degrees. So if that's not review, just note that the interior angle sum of any triangle is 180. We can classify triangles by their number of sides. An equilateral triangle has 3 sides that are the same length, or 3 congruent sides. An isosceles triangle has 2 congruent sides. And notice it says at least 2 congruent sides. So technically, an equilateral triangle is an isosceles triangle, but we normally give them their own designation. And then a scalene triangle, you've maybe never heard this word, that's just a triangle where none of the sides are congruent. So if we wanted just to rearrange these, this one is equilateral, all 3 sides are the same. This one is, we don't know anything, so scalene. This blue one, it looks like the left and right side are congruent, that's isosceles. Here's another equilateral, all 3 sides. Yellow and green are isosceles. Purple is equilateral, and this brown one is scalene. We can also classify triangles by their angle measure. So if it's a right triangle, it has 1 right angle. An obtuse triangle contains 1 obtuse angle, so 1 angle bigger than 90 degrees. An acute triangle is 3 acute angles, and an equiangular triangle is where all the angles are the same. So for example, this one would be equiangular. You can see all of the angles are marked in. This blue triangle would be obtuse. This is an acute angle, that's an acute angle, but this angle up here is obtuse, so you only need 1 of those. This red one looks acute, all the angles are acute. This green one, you can see the little 90-degree mark, it's marked in, so that's right. Same with the brown. And then this one here, that's clearly an obtuse angle, so the yellow one's obtuse too. So if we were asked to classify these triangles by sides and angles, this one here, we don't know anything about the sides. We can see all the angles are less than 90. So this would be a scalene, meaning none of the sides are the same, and acute. This one here, 2 sides are the same. That's isosceles. All the angles are less than 90, so it could be an acute isosceles triangle. This one here, we don't know anything about the sides, but we know it's a right angle, so it's a right scalene triangle. And this one here, we have 1 obtuse angle. We have 2 sides that are the same. So we have an obtuse isosceles triangle. And once again, that's just using our vocab from the previous 2 slides, classifying it by angles and sides. So in a right triangle, we call the longest side of the right triangle the hypotenuse. It's probably a vocab term you've heard before, especially if you've worked with the Pythagorean theorem. The 2 other sides of a right triangle are called the legs. The legs are the sides that make the 90-degree angle. It's a little confusing because on an isosceles triangle, we call the 2 sides that are congruent, we call those the legs. And then we call the 3rd side the base. And the base does not have to be on bottom. So my picture is not perfect, but for instance, if these were congruent sides, this would still be the base. The base does not have to be on bottom. It's just that 3rd side for an isosceles triangle. A triangle is 3 sides, so it has 3 vertices, or vertexes. Sides relate to a vertex by either being adjacent to the vertex or opposite the vertex. So from vertex A, the side opposite vertex A is the side that doesn't make vertex A, so BC. The adjacent sides of vertex A would be like AC and AB. However, if we were talking about vertex B, vertex B, the side opposite B is AC, and the sides adjacent to B are CB and BA. So adjacent means next to, the side's next to that angle or that vertex, and opposite would be the side that's not touching it. We have a couple theorems relating to the angles of a triangle. So the first one is the exterior angle theorem. It says the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Well, what the heck does that mean? What that means is one of these angles on the outside, let's take this green angle over here. That green angle is equal to the sum of this interior blue and red angle, basically the angles it's not touching. So for a little visual demonstration, we could take this blue angle. Maybe I won't have this perfect. I'll try. Blue angle plus the red angle, and that gets you that outside angle. The reason this theorem works, and if you're ever in like a bind and you forget this theorem, the reason this theorem works is because the angle sum of a triangle is always 180. So that means green plus blue plus red is 180. That's what we saw on the first page. But also this angle here and that angle here are a linear pair. So this green angle plus this whole thing is 180. So that means this whole thing has to equal the blue plus the red, because in both cases they're equal to 180. So to use this theorem with a picture like this, you have x here, 65 here, and then 2x plus 10 over here. If we want to find the value of x, we can use that theorem by saying that 2x plus 10 is equal to x plus 65. And what I meant where if you do forget what you're supposed to do, you know this angle here is 180 minus whatever 2x plus 10 is. And then from there, you could use that with 65 with x to get added up to be 180 using the angles inside of a triangle. But if you remember the theorem, you don't have to deal with that. So if you remember the theorem, you can just set it up like this, just as easy as that. Play some algebra, subtract x from both sides. X plus 10 is 65. And then when we subtract 10 from both sides, x is 55. So that's part one of this video. Part two of the video is going to be talking about what does it mean when figures are congruent.